Okay. All right. Hi, everyone. My name is Miriam Cristofoletti, and I'm a final year robotics student at the University of the West of England. And today I'm going to tell you a bit about my journey into engineering and why I love it so much. I'm going to start with a bit of a background. As you can guess from my surname, I come from Italy, where I was born and raised in a little city near the Garda Lake. It was great because almost every weekend my parents used to take us to the lake to have a nice family time. I spent there most of my life, and then roughly 5 years ago I moved to the UK, first to Exeter and then to Bristol, two amazing places where I always feel like I'm at home. And this is me. In all these pictures, I was between 6 and 9 years old. I was a very active girl, a lot into sports. In particular, I used to do gymnastics, rollerblading, and swimming at a competitive level. Also at home, I was always up to something, busy crafting and building stuff with cardboard board and Lego. Even though I was quite good with numbers and science in general at school, I don't remember myself thinking of becoming an engineer. But I do remember I've always wanted to invent stuff, create things. I wanted to become an inventor, really. Then, with the years, I learned that some people don't always agree with you. They don't always support you with your decisions. I'm thankful because my parents and my family in general has always been very supportive and supported me in every my decision. But some people around you do try to stop you and do try to break your dreams. And but you have to take this as a form of strength. You have to take it on the opposite side. If someone says no, you can't do something, you have to say watch me, and you do it. And here it comes one of my favorite movie quotes from the Pursuit of Happiness. So Will Smith says, don't ever let someone tell you that you can't do something. You got a dream, you got to protect it. When people can't do something themselves, they're going to tell you that you can do it. And this is so true. In fact, when I started growing up and I had to choose my secondary school, I wanted to go to a scientific and technological school. But I clearly remember some people telling me things like, you're a girl, that's a boys' school, you can't do it. And especially my maths teacher, I remember her laughing at me because I made a mistake in a calculation once, and she went like, you can't even do multiplications. And I got hurt in my soul for the first time. But I stood up thinking, I don't care what others say. I applied to that very school. And yes, it was a class with more than 20 guys and only 4 girls. Plus, I was the only Muslim girl in the entire school. But I loved it so much. I had an amazing time with my classmates. I built good fundamentals in science and technological subjects. And at the end, I graduated with a first. So it was all great. After that, some nasty comments and skepticism came again from people when I wanted to apply to an engineering degree. And when also I wanted to I wanted to move abroad. Why going that far? You won't make it. Girls don't do that. You won't like it. That's a man thing, and things like that. I mean, I couldn't care less. So I wanted something, and I pursued my passion. I studied materials and nanotechnology in Italy. And then when I moved to the UK after working a little bit and learning English, I started robotics at UWE. So what does this make me and all the other students, like all the other people studying engineering, an engineering student? Once our head of department highlighted a really important point. The engineering student should actually be called student engineers, because the reality is that you are already engineers. You don't need a certificate that says that you have the qualities, the creativity, the ambitions, the problem solving, the skills of an engineer. you already have curiosity, passion, interest, and because of that, you are driven to engineering, which is, by the way, amazing, and I'm going to show you why. So in my robotics degree at UWI, we learn to build and program robots from the very first year. So here there are a few of the projects that I made, and some individual and some in groups. So this is a robotic arm programmed to manipulate objects. This one here is a Lego mobile robot that is able to follow a line on the floor. That's it. And these are like little clips about another project, another mobile robot that is able to run in a maze, find the center, and find the quickest route to the center. As you can see, none of these projects worked at the first time, basically, but really it takes effort and persistence. So then between my second and third year, I went in industry to work for 1 year in a company called Renishaw. I was in the laser and calibration department, and I was working in the electronics team. These are so there I worked for 2 projects, and there were 2 boards, 2 test rigs, able to assess the operation of 2 different machines. And it was great. It was a great experience because I had to see the professional environment, to see how it is like, and also to develop my practical skills and knowledge as well. Another great experience is being part of the Bristol Robotics Laboratory at UWI, and 2 years ago, I took a summer internships where I was working in a project with one of the researchers, and I'm also working there now for my dissertation project, and I'm going to show you a little bit about it later. So these are some of the past and current projects done by researchers in the BRL. So this one here is a humanoid robot involved in a human-robot interaction project. And this one here is a robot with whiskers. So it's inspired by rats' whiskers. And here at the bottom, there are many tiny little robots able to work together without having to follow a leader, basically. And, you know, like ants and bees, they all work together. And this one here at the right is my favorite. It's Pepper. It's a humanoid robot, a lovely humanoid robot, used as a companion for elderly people in their homes. And it can also dance. I don't think you can hear the audio, but yeah, it was a bit showing off the dance. More recently, I joined another team for another project for a robot competition. So this is about designing and building and programming robots able to enter into a new environment for rescue missions. So this one is a spider-like robot that was provided to us by a company called Robotics, and we're going to have to program it and modify a little few things to be able to complete some tasks and for the competition. Then this is what I do as part of my dissertation project. The aim of the project is a robot arm able to learn from a human through a camera how to manipulate objects. So there are a few little tests here. This one is the camera, it detects the center of my hand. And then this one here is another kind of tracker that detects instead the color of an object. Then I have here other 2 tests. In here, the camera detects where the position of the basket on a table, and wherever I put it, it will give basically the distance from the camera in millimeters. And another test here is to try and track the hand joints, always for a manipulation purposes. So this is what I do. This is engineering, and this is what I like to do. Basically, but where do I get my inspiration? Where it's basically a little bit of from everywhere. I like a lot sci-fi movies and cartoons. Since I was a child, I've always watched kind of futuristic stories and series. Most recently, Marvel's, and Princess Shuri is my favorite. But really, this is all like fiction. But there are some incredible, real people that are doing an amazing job that we can take inspiration from. For example, Elon Musk, the father of Tesla, SpaceX, and many other companies. I know some people, they criticize him for many different reasons, but what I like is his strength, his determination, his kind of attitude that when everything seems over, when everything is broken, he stands up and says like, whatever, let's do it again, let's start again. And then also the Google founders, Brin and Page, the incredible and remarkable tool that we have today as Google, like it's something that we can't do without in our daily life, really. And also Steve Jobs for Apple products and many other things. I mean, all these people, they started literally from a garage, okay, and then built all the way up. And I can add Microsoft's Bill Gates, Jeff Bezos for Amazon, and many other businessmen. But really, what we don't see is all the other people that they were standing behind this. And they came many, many, many years before these guys here that did the fundamentals where all these people, they stand on. For example, Mary Jackson, the first NASA Black female engineer, and then Katherine Johnson, mathematicians, also NASA mathematicians, who calculated many of the American space missions, and Dorothy Vaughan, also mathematician, who NASA mathematician actually, who was the first Black supervisor at NASA. I mean, if these ladies and many others didn't do what they did, Elon wouldn't be able to send his rockets to space, seriously. And another example is Karen Spark-Jones. She's a computer scientist who put the ground for search engines. If she didn't do what she did, all her research, we wouldn't be able today to say, Google it, okay? And last but not least, Ada Lovelace, with like the founder of computer, the mother of all like computing technology. If she didn't do what she did, none of this would ever happen. And today the world would be a very, very different place. But all this, what we see is just the success of these great people. We just look at what they have achieved. This is what we see, the peak of the iceberg. But the reality is that there's much more behind the scenes. What we don't see is all the persistence, the dedication of these great people had, all the many failures, the sacrifices, the disappointment, discipline, hard work, dedication. They actually started from nothing but an idea, spent a lot of time trying and trying and trying, and then the reward came of this hard work. And it always comes, seriously, for us as well. If you have a great idea, a good idea, you want to change the world, you don't wait to find the perfect role model to follow, because it's seriously hard to find. You can be your own role model, take inspiration from here, there, and be the first, okay? If I was to wait to find a person that in the world that matches each one of my aspirations, identity, background, and anything, job, and anything, I would be still there looking. It has to be a woman, a Muslim, Italian, engineer, strong, this and that. I mean, I have always thought about myself, who do I want to see in the mirror in 5, 10 years' time. And this could be you as well. Whatever is your passion, your interest, just never, ever give up. Be the first one. If something goes wrong, know that it's just the first step of the ladder. One of the many things hidden in the iceberg I've shown you before. One day you're gonna change the world, and I'm gonna sit here listening to you telling your story about your first failures, sacrifices, but also your achievements, your success. And it's gonna be great. I'm sure, believe me. So we have at UE something called Women in Science and Engineering, which is a society some friends and I formed a couple of years ago. We promote and support STEM subjects, so science, technology, engineering, maths. And as you can see, we do a lot of events, talks, conferences, company visits, and great activities to support. And we are always supported by our engineering department. This year we have an exciting project in our hands. It's a car-graded backlight designed by Philippa Griffiths, the winner of last year's Leaders of World competition. He's part of the team working with me. So basically we got inspired by her project, her design, and we're going to build a prototype which will be exhibited in the final celebration next June in Bristol. And we are so excited. We've started doing some little tests. As you can see here, there is a pressure sensor, because at the end of the day, the engineering principle behind her idea is really simple. It's just a pressure sensor and an LED that turns on depending on how much you press on this sensor. And here another test with like different. The more I press, the more LEDs they turn on. Sorry, and yeah. So my message to you today is: follow your passion, work hard, enjoy your time, and never, ever, ever give up. Take part to this competition and come up with a great idea, because next year it could be your design that's going to inspire other engineers to build it. Thank you for listening.
Wow, thanks, Miriam. That was brilliant again. Could I ask you to come out of your screen, so your full face? So everybody, perfect. Yes. If anybody has any questions, and I think somebody's already started, Alexander Manor, please type them into the chat facility. For those schools that joined later, then I sent you a private message on the chat. Could you make sure that the drop-down box on the bottom of the chat says to everyone, so that Miriam can see it? Yeah. So I'll leave you to it, Miriam. There's one question. Well, I think it's a few questions there, but
yeah. Okay. All right. So we have, how many hours do you work a day? Right. It depends. It's a bit flexible. Because other than my project that I show you now, we also have, I'm in my final year at university, so I also have some modules to take, some exams, some other courseworks that I have to work with. And so it really depends on the day, but mainly I try and stay at university from like 8 or 9, mainly 9 to 5. It depends. Sometimes there's a deadline and I stay there like very late in the night, but it's, as I said, it depends. Is engineering easy? Oh, this is a good question. Engineering is challenging, okay, but it's so much fun. It's easy if you find that particular thing in engineering that you love doing. For me, for example, sometimes I get a bit upset with things that don't work, or with something that I might like struggle a little bit to understand, but I do like what I'm doing. Even though it's challenging, I do like what I'm doing, and I wouldn't change it with anything. So the main point here is, inside engineering, there's a whole world. You should find whatever you really like, because then you don't get bored, first of all, and you keep on going because you love what you're doing. And also it's kind of, it pushes you to look for new things to learn, and that's a very important thing. How long does it take to become an engineer? Right, so I guess most of you are in primary school. So after primary school, you go to secondary school, and then you can go to college, and then you can go to university, and after that you can get a qualification to become an engineer. Or sometimes you can do an apprenticeship. So instead of going to college, you can go to a company, and they will teach you basically the work, how to become an engineer. But as I said before, really, engineering is what you do, what you like to do. Even now you can be an engineer. Okay, you just start building something. There's loads of material online. We are thankful for that. And you see a project that interests you, start doing, start building, start asking questions to your teachers, to whoever at home could help you. That's a very interesting thing to do. Why did you choose the job? It's because I love it. Yeah, I love things. I love to see I'm programming things, and then a robotic arm would move, or a mobile robot would run away in a maze, or things like that. So that's why. Did any of your creations fail? If so, how and why? Oh yeah, many, and still they do at the moment. So nothing works the first time. So like, what do you see in movies, that a person like a computer scientist or an engineer and just type things like crazily on a keyboard and everything works? No, it doesn't work like that. It takes time. But then it's a good reward. It's like you're gonna be satisfied by yourself, by your hard work. And yeah, so how long have you been an engineer? I would say my whole life. But technically, like as a student at U is this is my 4th year now. When did you start making robot models? So robots specifically, only when I started university here in Bristol, so 4 years ago, really. Do you have a particular problem in mind that you would like to develop a solution for? This is a good question. Yes, I have a couple. Sometimes I'm sat on a sofa chilling, or watching something, or reading a book or something, and I start thinking, what if we would do this and that? It's everything is in your mind, and you start in developing an idea, and then this is how all these great people have achieved so much. So something that I've got in mind, there are many things actually. It could be, I would love to work with prosthetics. So basically prosthetics are for some people, they are struggling because, for example, for some accident or for other reasons, they've lost a limb, so an arm or a leg or things like that. And so to make them, like to help them to live an independent life, there are some tools that can be attached to the body, for example, a robotic arm or a robotic leg. And it would be so interesting to see how they could be like controlled by your mind, basically by your thoughts. There are some researchers working on this, and this, I think, it could be very, very interesting. Next. How many projects have you been involved in? So many, especially this year. At the moment, so I've got my dissertation, I've got the rescue competition, I've got some of other modules for my university work. Another project management project as well, so quite a few. how long did it take you to make your first robot? So the first robot was the Lego, was the line following robot that I showed you before, made like with little Lego parts, and it took us, it was the two of us, it was probably 4 months, something like that, but we were working together. And the good things of working together is that you can split the workload, and also you can learn from each other, and also you can develop extra skills, and that is really good. Where is it? What is your career like? Do you enjoy it? Yes, I enjoy it so much. And what's like? Well, I like to see myself, and I'm building robots all day long, and I wish I can continue that. What is the hardest part of any project? The hardest part is debugging. So what is debugging? Debugging is when you start building something, whether it's hardware, which like it could be like the electronics part, or you are trying to build the mechanics for a robotic arm or whatever, but it also could be in software. So debugging is when there is something that you've already built or programmed, and there is an error. So for example, if it's a code, it doesn't work, it doesn't even run. So you have to go through each line of your code and start seeing what does work and what doesn't. So you start from the top and you see, okay, this works up to here, it works, okay, fine, let's carry on. Up to here it works, okay, that's fine. So you keep on reading all the lines in the code until you find the bug, which is the error basically. And same things in electronics. So you start testing each connection, each joints, each component. Sometimes they could like be broken, or things, and then you just like try and fix it basically. What personal attribute do you think do you need to become an engineer? I think creativity and curiosity are the main ones. You have to dream big, really. You start with that. You start with an idea, but you have to have an idea, okay? And then you start doing research. So research is really important because we don't know everything, okay? So when you say, oh, I want to create something, and you start saying, what do I need? I need this, that, and then how do I build this part of the project? So you start reading, you start testing. So that's, I think creativity, research are quite important, and then communication. If you want to explain, most of the times you have an idea, but you have to explain it to others. So sometimes they give you funding or money, or sometimes it's people that, like, when you want to publish a paper. So communication is really, really important. And team building, yes, and you have to work in teams. I don't think there are any engineers that they work alone, okay? So almost everyone works in teams, and teams that are really diverse, in the sense that, for example, I'm a robotics engineer, I work with electronics engineers, I work with aerospace engineers, I work with mechanical engineers, computer scientists. Sometimes they're not even engineers. Sometimes you have to really deal with people that have a completely different background from you. So you really have to be able to talk to them and agree. Okay, I think these are the soft skills basically that you need. Why do you focus on robots? How long does it take to make an invention? How long does it take to make an invention? It depends. But yeah, it could take months, I think, if you work hard, and it could take longer it could also take less, actually. Depends how many of you work on the same project and how much time you dedicate on that project. Why do you focus on robots? Because I love them. Because I think they will be very, very useful one day for each one of us. And they're not there to replace us. They're not there to take our jobs. They're not artificial intelligence is not evil. They are there to make our life easier, to help us avoid boring things, dangerous things sometimes, instead of a person going into a dangerous place or in a rescue mission, for example. We could just send a robot, and if it gets damaged, that's not that big deal. If a person dies, though, that is a problem. Right. If you weren't an engineer, what career would you have chosen? I think, I don't know. I've never thought about it. I would probably, I've been asked this question a while ago, and I said that I would be something creative, definitely. I would be doing something, maybe like some sort of, because I also like drawing and like not coloring, but like doing like some painting as well. So it might be something artistic that I would do, but more recently I'm involved in this kind of activities into schools. So I think, and I really like it, so I might actually say that if I wasn't an engineer, I would work in schools with children, I think. Yeah. Always in sciencey subjects, but yeah, in schools, I think. What subjects do you need to do engineering? So maths is really handy to have it, and science in general. Maybe less biology and chemistry, but very much physics. And I think, well, yeah, if you can do some sort of electronics, or actually no, programming, yes, definitely that's a very good subject that it can be handy. I didn't know any coding before starting university, but so we started from scratch, literally, and with C programming, and then that was like helped me to learn other programming languages, and yeah, it gave me the basis to build my next knowledge as well. So yeah, maths, physics, computer science, really, yeah. How hard is to program a robot on the computer? It depends on your background, right? So if you are a coding monster and you love coding and you're really good at it, it's just like easy peasy. But if you're struggling a little bit and you haven't done it before, and it will take a while just to get used to all the interface and all the actual language, because at the end of the day, really what I found out is that programming is seriously learning a new language. So I don't know, you all know English, and then if you started learning French or Italian, if you want, it takes a while to be fluent, right? Same things with programming. You're not going to be fluent in the sense of talking, but you will need to set your mind of like knowing all the functions, knowing, getting used to, like, if an error pops up, you know exactly what that is for, and what is caused by, and yeah, the most you practice, the easiest it gets, really. I was struggling a little bit at the beginning, and now it's getting better and better, hopefully, so far. Right. Oops. Where is it? Oh dear, I lost. Okay.
You okay? Can you find it?
Yeah. Sorry. What materials and resources do you use and need to design and build robotics? Right. So materials, it could be, it seriously could be anything. I saw online the craziest things, really. Robots, like machines made with pasta bits and things, weird. But the most common, obviously, is plastic, steel sometimes, metal, sometimes wood as well. I saw carton board robots, which is crazy. But the most common is plastic anyway. I need to design resources. So the main component of a robot are the motors, if you want to move something, actuators. So if you want to grab something, you need a gripper. If obviously you want it to be a mobile robot, you need wheels. It depends on what you want it to do. Like if it flies, and you will need like to be able to fly and things like that. So it really depends on the task that you need it to do. How do you turn fails into fun and successful? This is an amazing question. So at the very moment when you fail, you don't feel much fun. I know. But when you start thinking that your goal and what you want to achieve, okay, is important, and you like it, and it would be useful for other people, you kind of get in that mindset that if there's a failure, it's fine. Just don't stare of your robot or whatever doesn't work and get depressed and get sad, and just don't stay focused on your failure. Stay focused on your goal, okay? If the failure is here, right, and something is broken, you just try and fix it, okay? Don't focus on the fact that you failed. Focus on the fact that it just doesn't work, and you want to fix it, right? And you start looking, you start asking. I found quite important learning to ask other people. I know it sounds crazy, but some people like me, I wasn't into asking a lot, mainly because if I ask, I look weak. If I ask, I look maybe stupid. If I ask, I don't know much about it, and maybe I will bother the other person. Maybe I will disturb it. What is he or she going to think about me? Forget about all that, okay? You need to solve your problem. You're stuck and you don't find a solution. Ask, okay? Your teachers, your someone at home, whoever is tutoring you, it doesn't matter. Ask, or look it up online, or there's loads of information online, so ask. Who inspired you most? Okay, I think that the three ladies that I talked to you about, the NASA mathematicians and engineer, they are the most inspiring ones. So in the book, in the movie, and all the interviews that I watched about them, they look so strong. They look so confident. They look so, I don't know, determined. They spend many years struggling, right? At the beginning, that's fine. But then afterwards you see that the rewards come, and all your efforts and the results, you see them, right? So that kind of inspired me a lot. And yeah, that's powerful, really. How old were you when you made your first invention? Right, invention in general, I was probably, I don't know, I was 5, 7, 8, something like that. I was in primary school. It wasn't an invention, right? I call it an invention because for me it was something new, but it was just cardboard put together, and I drew it first, and I said, okay, I want to do. It was just like a little, it's not a doll house, but it was like a little house, okay? And I started doing with cardboard, and because I found in the garden, I found in the garden a little frog that day, and so I wanted to make a little house for the frog, and I started thinking, okay, it will need to breathe, so I have to put windows, and I started cutting stuff, and I put everything together, and then I tried kind of push the frog with a little stick inside the house. And it's not an invention like, I don't know, a rocket or something, but for me at that time it was something amazing because I made it. Okay, it was just a drawing at the beginning, and then I started cutting stuff and putting sellotape all around and things like that, and then I was proud of myself. What do you use to make robots? I said it. It was more like the resources, the materials are more about plastic. And also if you wanted to give it some intelligence, okay, so you will need sensors as well. So to sense the environment, to detect a wall. If you want a camera, you can put it, so it will recognize objects, or it will, or there are sensors to detect how far something is. There are, as I showed you before, there are pressure sensors. There are loads of sorts of sensors depending on the task you want to achieve for your robot. And also you will need a microprocessor, which is like a board. It's like a very, very little basic computer inside your robot that if you find, so basically you program that little board saying, if you find a wall, turn left. If you don't find it, carry on straight. Okay, so it's like you have to give it some instructions, really. Have you ever made a little rocket? No, I haven't. But it's in my wish list, actually. I would love to work for a rocket company, or the first spaceship. Imagine, that would be so cool. Do you think robots will backfire like in Terminator movies? No. I don't have that idea of robots. I have the idea of robots more like they help people, they support us, because at the end of the day, if you think about it, we give them the quantity, the amount of intelligence we want. Okay, all the futuristic kind of movies that we see, that at some point artificial intelligence becomes evil because it will learn more than what you wanted, or it will like attack you or whatever. I don't think so. We should stop before, and we will definitely. What was your favorite subject at school? It was maths, actually, because it was maths and a little bit of biology as well, because it was I was quite good at it, and I like numbers. I love numbers. I find them very objective, in the sense that 2 + 2 is 4, and that's it. It's not like, I think maybe, numbers don't lie. I like that. What is your least favorite thing to make? So as I said, to make a robot, you need electronics, so all the hardware, and you need programming, okay? So I like more doing the electronic bit other than the programming one. Yeah, so the least enjoying, like the part that I least like is that I like less is coding, really. Yeah. Some part of the coding, actually, not like in general. Exactly. What do you prefer, programming or robots? Well, not robots, but electronics. Yes, I like it a bit more. How many volts of electricity do you need to get your robot working? It depends on the task, but sometimes you need just a very little amount. So sometimes you work just with 5 volts, but a whole robot usually is 24. Yeah, normal ones. Sometimes a bit less, but yeah, mainly that. What is your favorite animal? Would you like to use prosthetics to help animals? Oh, that's cute. Yeah, I've never thought about it actually. It would be quite interesting to see prosthetics applied to animals. My favorite animal is I like cats, and I also like hamsters. I used to have a little hamster. It was beautiful. His name was Oscar, and I was always running in the house with his like ball inside the ball, like running. It was great mate. Is anyone else in your family an engineer? Right. No. It doesn't, you don't need to have someone at home or like around you that is an engineer for you to become an engineer. It's really just what you want to do, okay? And as I said before, even if you are the first in your house, in your family, in your neighborhood, between among your friends, doesn't matter. Just do it because you like it and you find it enjoyable, you find it fun. So just don't depend on others to do something that you like. That's very, very important. I learned it myself. How long was your longest project? I think the longest is the one I'm working with for my dissertation. So the robotic arm that manipulates objects. Yeah, that's the one that takes longer. I think it's because in between I'm doing other things. If it was just that, I would probably do it faster, I think. Yeah. What is the fastest moving robot you have made? Fastest moving robot. I think the one that runs in a maze. Yeah, that was quite fast. So it wasn't fast while doing the actual task of moving around and detecting walls and also remembering the way it was going. But if we were just to leave it going, it was quite fast actually. Without all the other tasks, if it was just to move forward, it was moving quite quick actually. Oh, some schools had to go. Oh, bye. I read them late. Have the robots you created got a name? Oh, yes. So sometimes when you have a project where you only have to program something, you buy robots. Okay, you don't. So you don't always have to build a robot from scratch to do something, right? Sometimes there are companies that they build, like Pepper or the robotic arm that you saw before. There are companies that they build them, and they kind of give them some very general programming interfaces, and then students, researchers, other companies, they buy them and then they program it with their specific tasks for projects. So for example, the robotic arm, so for example, the robotic arm is called Jaco. It's the name the company gave it. And again, Pepper, it's the name that they gave it, yeah. But the robot running in the maze, we call the raton, which is mouse in Spanish. It was quite nice, actually. What is the best thing about being an engineer? I think the best thing is that with your effort, with your creativity, so basically with something that you enjoy doing, you could help someone else. So whatever you invent, whatever you build, whatever you program could seriously help someone else to do something great. For example, I don't know, like, for example, some robots, they are placed in houses to help elderly people to live an independent life, or to assist some people with some disabilities as well, or sometimes for medical purposes as well. So it's nice that you're not only having fun building something, but out there is someone else that depends on your work, and in some sense is grateful for your work, and his or her life will change, will improve thanks to your work, which is kind of amazing, I think. Do you get to travel the world with your job? Yes. So not me personally, I'm still kind of a student, but engineers, and especially robotics engineers, they are everywhere. And depending on the company you work for, or if you make your own, if you start up your own company, you can get to travel a lot, sometimes to get resources, sometimes for competitions, sometimes for agreements. Sometimes you want to open new offices around the world, sometimes for conferences. Actually, most of the travels are for conferences as well, and to showcase your project, your work, your product. So really, you can really go anywhere. Are you known around the world for your inventions? Not yet. I hope one day. I'm just scrolling the questions, because most of the questions are repeating. So what is the worst thing that has gone wrong? I think, yeah, sometimes when you overrun a circuit or your robot in general, sometimes components inside the boards, they get fire. So they kind of break because they overheat, okay? And sometimes you see smoke, which is really bad. I think that's the worst thing ever. And once I was like, I got burned with my finger because I was trying to remove it, and I touched it accidentally, and it was really, really hot. So I got a little. Yeah, but that's the worst. It could happen, really. Yeah. Sometimes the robot get damaged, but yeah, that happens. Have you met any famous engineers? Oh no, but I really would love to meet some amazing people, like some famous, like the three NASA ladies, the engineers and mathematicians. That would be so cool to meet them in person. Wow, would be a honor, really an honor. But I do meet other engineering students, other engineers around university, in some companies as well, and they're also inspiring. It doesn't really need a person to be famous to be your role model, right? It does. I mean, if you see someone that has achieved something, okay, and you think, and the way he or she speaks inspires you, you can take that as a role model. I personally see many women in my engineering department that I so much see them as an inspiration, because they are, especially women, because it's like, I try to see myself in, I don't know, 5-10 years, whatever. So they are mothers, they are wives, they are head of departments, they are lecturers, they are like important researchers, they are important engineers in companies. They, you know, it doesn't, and at the end of the day, they are normal people, right? But they have achieved, they work hard and they have achieved amazing results, and that what inspires me. How many engineers does it take to build a robot? I would say at least it depends on the, okay, it depends on the robot, right? But normally for a university project or a research project, usually they are like 4-5 students, or like engineers in general. And yeah, that's a reasonable number. Have you ever built a robot to go underwater? I haven't, but there was a competition a few years ago in the robotics lab at university, and they were it was a European competition, I think, and they were trying to build robots that they were going like able to go underwater. And that's a kind of a challenging task, because you have to consider they have to be waterproof inside, and they have to be resistant enough, robust enough to basically swim. They don't have to be too heavy, because of the way they will just fall down at the ground of whatever that is, a pool or the sea. They have you know, cameras, many things that you have to consider underwater. But it would be very interesting to see, to study. What is the smallest robot that you made? Yeah, I think it was the little mobile robots. But there are but because we are still learning anyway, we're still practicing. But there are many, as I said, as I showed you before, the little robots that are made to work in collaboration together without a leader, like ants and bees. They are this big. It's not much, really. And there are also many others in other laboratories that they are even smaller. So really, especially now, the more, like with the development of computers and microprocessors and all this kind of technology, it gets smaller and smaller and always like more and more powerful. So we can build always like smaller and smaller things. Where do you work? I work in the so it depends. Sometimes there are many things that depends, but it's true really. Mainly I'm based in the robotics laboratory at UE, but sometimes I work at home. Sometimes so when I was on placement, I was working in the company at Renishaw. Yeah, but mainly in the robotics lab. Yeah. Oh, can you build a robot to aid in collecting plastic from the sea? Yeah, I mean, I've never done it before, but this is a great idea actually. It could at the end of the day, building a robot is always the same. It happens always in the same way. Okay, it's just extra consideration depending on the environment you want to put it into, the sensors that you're gonna need, the all the materials that you will have to apply, and all these things you have to consider, and then it's always in the same way at the end of the day. Yeah. These schools, Bridgewater Hippos, they have to go. Yeah.
I think that's in terms of questions.
Yeah, I think
Once
so.
again, Berlin is brilliant. Thank you very much.
Thank you.
And Ben Madigan, Cumbria, and Forrest, I believe it is. Thank you very much.
Thank you, Chris.
You stayed to the end, and we'll call it a day here now.
Yeah.
And I'll be in touch soon, Miriam. Okay, I'll send you an email.
Okay. Thank you so much.
Thank you. Bye, everybody.
Bye.